So this is problem number 4. It's from the 2016 AP Calc BC exam. It's a no calculator question, and all they give you to start off with here is a differential equation. The bad news about this differential equation is we cannot separate our variables. So it's a non-separable differential equation. So we'll just have to kind of keep that in mind. We won't be able to take the direct approach if we wanted to at certain points within this process of solving the differential equation and then answering questions based off of that solution. So non-separable, a little bit of an issue, but we should be able to get by it. And in part A, they ask us to find the second derivative in terms of x and y. So this is something you've probably done a handful of times before. We want to take the derivative of both sides of this equation with respect to x, because taking the derivative of the left side gives you your second derivative right away. When you take the derivative of the right, the derivative of x squared, I wouldn't be concerned with us accidentally messing that up, but the derivative of that next piece, since y is a function of x and we're doing the derivative with respect to x, we're going to have to use implicit differentiation. We get minus 1/2 dy dx in that spot. Now the only other thing is that it asks for the derivative in terms of x and y. And so we would have to recognize that the second derivative is not supposed to depend on the first derivative in our answer. It's supposed to depend on x and y. So that's an easy issue to resolve. You can just place what dy dx is equal to in place of dy dx in your answer. Watch your grouping symbols. If you wanted to simplify, I guess you could distribute in there. But here is your second derivative in terms of x and y. Part B says that y equals f of x is the particular solution to the differential equation, and the graph of f of x passes through the point -2, 8. Then it says, does the graph of f have a relative min, max, or neither at this location? Justify your answer. So what you always are going to hope for is that it's not even a critical number. That's the easy way to say, hey, we don't have either. And so you put -2 in for x in the first derivative, you put 8 in for y, you do get 0. So it is a critical number. That means it very well might be the location of a max or a min. We're not really going to be able to take the direct approach to answering this. So I mentioned this early on in the video. We don't have the ability to construct a sign chart for f prime of x because this first derivative depends on both x and y, and we can't solve this differential equation to build the function y by using separation of variables. So we're going to have to kind of think outside the box here. So my line of thinking is, hey, this tells us we have a horizontal tangent at this ordered pair. I just computed the second derivative in part A. Maybe I can make use of that to develop my conclusion. And if you find the value of the second derivative at -2, 8, so this is just the answer from A, right? 2x minus 1/2, and then the value of dy dx at this ordered pair is 0. So I get -4 for my second derivative value. This combination of things tells me that we've got a horizontal tangent at -2, 8. That's from this first calculation. The second calculation tells us that the curve is concave down at that ordered pair. Well, if you have a horizontal tangent and you're concave down, that tells you that your function has to have a local max on its graph at that location, and that's actually called the second derivative test. So we usually like to use the first derivative test, and in this case the second derivative test was really our only option based on us sitting at the end of AP Calc BC. Part C of this question, they talk about a new function, g of x. So it's a solution, it's a different solution to the differential equation because it has a different ordered pair on its graph, and we want to find the value of this limit. So if you try to find the value of the limit the easy way, just by putting -1 in place of all the x's, you do have to make use of this. Right? When you see g of -1 there, you've got to substitute 2 in place of that. You do get 0 over 0. So, all right, not a big deal. Use L'Hopital's rule. So you take the derivative of the top, you get g prime of x. You take the derivative of the bottom, you get 6x plus 1 to the first times 1 if you use a chain rule, which simplifies to just 6x plus 1. You evaluate this at -1. You get 0 on the bottom, and then you get g prime of -1 in the top. Well, what's g prime of -1? Well, you know that at this x, the y value is 2, so if you evaluate your derivative at -1, 2, that's what you're going to use for your value of g prime of -1, and unfortunately you end up getting 0 if you evaluate the derivative of g at -1, 2. So all right, not a big deal. L'Hopital's rule one more time. So you apply L'Hopital's rule once again, derivative of the top, derivative of the bottom. This is good. bottom's now a constant. What about g double prime of -1 within that numerator? Well, now we have that second derivative from part A. If we evaluate the second derivative at -1 comma 2, we end up with -2, which simplifies to -1/3 for the value of our limit. And then in the last piece of this, I'm not going to really take you through everything here. It's just carrying out Euler's method for another particular solution to the differential equation. This time our initial condition is 0, 2. We want to use two steps of equal size. So if you construct this in table form, to get from 0 to 1 with two steps of equal size, we're going to have to go 0 to 1/2, the rest of the way to 1. We want an approximate y value on the function at 1/2, and then we're going to use that to generate our approximate y value on the function at 5/4. So this is the algorithm that you might use for Euler's method. And if you do that, that gives you an approximate value of 3/2 at the x of 1/2. And then if you use this ordered pair and apply Euler's method to it, that gives you your approximation for h of 1. And you can see all the calculations here. It's I guess, kind of tedious. You don't necessarily have to do all these calculations on the AP exam. If you left a crazy looking answer like this, that it will receive full credit. But I took the time to simplify that down to 5/4.